In this video, we're going to develop the quadratic formula by completing the square. So before we do that, let's review completing the square by solving this quadratic formula, this specific quadratic formula, by completing the square. Okay, by now you should know the drill. We inspect the leading coefficient to see if it's 1. Well, it's not 1, so we have to make it 1. How do we make it 1? We divide by 2. And of course, if we do it to the left-hand side, we must do it to the right-hand side. So we're dividing by 2, so we're going to distribute the division over the addition thusly. So it's going to be 2x squared over 2 plus 16x over 2 plus 24 over 2. In other words, if I divide a trinomial by 2, that's the same as dividing each of the monomials by 2. And 0 divided by 2 is just 0. 0 divided by anything is 0. Doesn't matter. Alright, so now I do a little bit of arithmetic. That cancels, and now I have exactly what I want. I have a leading coefficient that's 1. The rest is just a little bit of arithmetic. 2 goes into 16 8 times, so that becomes 8x. 2 goes into 24 12 times, so that's plus 12 equals 0. Alright, now, in order to make room for a coefficient that will complete the square, I have to get rid of this coefficient by moving it to the right-hand side. How do I do that? I subtract 12 from both sides. And I'm left with x squared plus 8x. This disappears because its sum is 0, and that equals minus 12. Okay, now I want to complete the square. That's why I made room for it over here. So to complete the square, I take the 8 that's here and I put it over here. Divide it by 2, squared. Well, if I do it to the left-hand side, got to do it to the right-hand side. So I got to do that over here too. Okay. So now let's simplify this. That's x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16. So that's going to equal minus 12 plus 16. That's going to equal 4. Alright, so I have a perfect trinomial square here. So that's going to be x, and what goes in the binomial? 8 over 2, which is 4. Alright, so that's plus 4 squared equals 4. I have my perfect trinomial square on the left. That means that I can apply the square root property. Take the square root of both sides, and the square root property requires that I recognize that there are going to be two solutions to any square. Plus solution and its opposite, negative solution. Okay. Having done that, the left-hand side cancels because the square root of a square is just itself. And plus or minus, the square root of 4 is 2. Subtract 4 from both sides. And what do I get? I get x, that goes away because it's sum at 0, equals minus 4 plus or minus 2. X equals minus 4 plus 2 minus 4. Oops, it's kind of funny looking 4. Minus 4 minus 2. Minus 4 plus 2 is minus 2. Minus 4 minus 2 is minus 6. Alright, so much for review. Now, here's a generalized form. I have ax squared plus bx plus c equals 0. Now, a cannot be 0 for two reasons. One reason is that if a is 0, then 0 times x squared is 0. And the square term goes away. We no longer have a quadratic equation. So, what's the point? And, of course, the other reason is I'm going to eventually divide by a. In fact, I am going to divide by a because a could be 1, but a could be 10. I don't know what a is. Just to guarantee that a that the leading coefficient is 1, I'm going to divide everything by a on the left. Well, if I divide everything on the left by a, I've got to divide everything on the right by a. Now, in our example over here, a is equal to 2. 2 divided by 2. No big deal. All right, just as I did over here, I have to do a little bit of arithmetic to clean this up. I'm going to distribute the division. So I got ax squared over a plus bx over a plus c over a. And that equals 0 over a, which, like over here, is still 0. 0 divided by anything, whatever a is. And I know a isn't 0, so this is legit. It's going to be 0. All right, this becomes 1, which is the whole point. I now have x squared. And now I have b over a times x. I mean, I just changed that a little bit. Plus c over a equals 0. All right, what did I do last time? I moved the coefficient to the right-hand side. Well, I'm going to do the same thing here. And I move the coefficient to the right-hand side. I know this is a coefficient because b and c can be any numbers. I probably should have said that. Can be any numbers. Doesn't matter. As long as a is not 0, we're in good shape. So how do I do that? Well, I do it the same way I did it here. I subtract c over a. All right, I'm adding opposites. That's how I'm going to get rid of it. So I subtract c over a here. And what do I have left? Well, I have x squared plus b over a. All right, that goes away. Oh, hooray. And that equals minus c over a. All right, now it gets a little harder to see. Well, maybe not. Well, again, just like I did here, I want to complete the square. Now, I'm going to add something, and of course, I have to add something here as well. Well, what am I going to add here? Well, I move this coefficient into here. So I'm going to move this coefficient into here. That's b over a. Then I divide it by 2, right? So I'm going to divide by 2, and I'm going to square this whole mess, and same thing over here. b over a over 2 squared. So I got to do a little bit of arithmetic. b over a over 2. Well, 2 is the same as 2 over 1. Now I have a complex fraction. And as you recall, with complex fractions, the numerator stays the same. I change the division process or operation to a multiplication, and then I invert or find the reciprocal of the denominator. So that thing is equal to b, numerators times numerators, 1 times b is b, a times 2 is 2a. So I have x squared plus b over a x. Yeah, that should have been an x over there. Sorry about that. Plus, this is now going to be b over 2a, right? Because that's the same as that. It's the same as that. And that's going to equal. Now, I'm going to move this over here and that over there. So I'm going to have b, oh, and that's squared, right? I don't want to miss this out because I forgot to copy a coefficient or an exponent. All right, minus c over a. All right, let's do a little arithmetic over here. This is going to be b squared over 4a squared, right? Because I have to take the square of everything inside. So that's going to get squared and that's going to get squared. Minus c over a. Well, let me multiply this by 4a over 4a. Because if I do that, I'm going to get the same denominator. I'm going to get 4a squared, because a times 4a is 4a squared. Now, if I multiply the denominator by 4a, I have to multiply the numerator, because this thing is now 1, and 1 times anything is anything. So I do not change the value of this term. I just change it to an equivalent fraction. So this whole thing is equal to b squared minus 4ac. Remember, multiplication is commutative, so I can change the order. And a times a is a squared times 4. And what do I have over here? This is a perfect trinomial square. Okay? So that's going to be x plus what? Well, it's going to be plus what's in here. B over 2a squared. Now, let me make a little room. All right, because I'm going to apply the square root principle. I need the room on the right-hand side, so let me put the equal sign over here so I can put the plus and minus. So, applying the square root principle, I put a square root on both sides of the equation. And then I recognize the right-hand side of the equation. I put this plus and minus, because the solution to any square is going to be two numbers, and they're going to be opposite numbers. All right, so the left-hand side, I have the square root of square. That goes away. And I'm left with x plus b over 2a. All right. Well, I can't do much with that numerator. So let me, oops, don't forget the plus or minus. Let me keep the numerator, let me keep the numerator the same. That's going to be b squared minus 4ac. However, I can do something with the denominator. The square root, right, of the denominator, well, the square root of 4 is 2, and the square root of a squared is a. All right, now, to solve this puppy, I subtract b over 2a from both sides, minus b over 2a from both sides. And now what do I have? I have x. These are opposite terms, so they're going to cancel because they add up to 0. And this equals minus b over 2a plus or minus square root b squared minus 4ac over 2a. Well, you notice I have the same denominators. So let me combine the terms. And I get x equals minus b plus or minus the square root of b squared minus 4ac. And they're all over the common denominator of 2a. And that, ladies and gentlemen, boys and girls, is the quadratic formula. Next time, we are going to do some calculations using the quadratic formula and applying them essentially to quadratic equations. Till then, see you later. Bye now.